morning, everybody. This is Divyavani, working as assistant professor in CSE department in Institute of Aeronautical and Engineering College. So, in this class session, we are going to learn about the non-deterministic finite automata, which are nothing but a finite automata without outputs. It is also a part of finite automata without outputs. That is a non-deterministic finite automata. So coming to the session, here we consider this NFA, a non-deterministic finite automata. It stands for the non-deterministic finite automata. It is easy to construct NFA than a DFA. That is nothing but in DFA, we are having many more constraints that we have to follow in construction of the DFA. So as I recall you back again that in DFA, every input state should contains all the input symbols exactly once, right? But we're coming to this DFA, NFA, we doesn't contains all those constraints. For that, rather than this finite automata is also this NFA is also called as a finite automata, right? When there exists many paths for specific input from the current state to the next state. That means here if we take an input symbol, for example, if you are having a state called Q0, right? In NFA, on seeing an input symbol, let me take input symbols are A and B, right? In Q0, if we see an input symbol on A, it can goes to any number of states, or else sometimes it may also go to the null state, right? This is the constraint present in the NFA. By seeing one input symbol, it can goes to any number of states. That means any number of times the transition may occur, can be able to occur. But we're coming to the DFA, whenever if your stays on a state, on seeing an input symbol, it has to go to some other state exactly once. But in NFA, it can goes to any number of states, any number of times. And another one, here NFA is not DFA, but each NFA can be translated to the DFA. So what it is going to prove that the NFA is also a equivalent powerful as a DFA, it is proving. That means this NFA can also be able to translate into a DFA. This NFA in the same way DFA, but with the following two exceptions. So these what are those exceptions? The first one, it contains multiple new states. By using a one input symbol, it can goes to a multiple new states by seeing a same input symbol A, same as what I have told here, right? It is not mandatory that all the input symbols are to be defined for the states, right? So if I having an input symbols called AB, and if I having a state called Q0, in DFA I should contains a transition for A as well as a transition for the B. But in these NFA, it is not mandatory that all the input should be symbol should be occurred on a state. So here, if the state contains Q0, and if I have a state itself, even though if I have input symbols called AB, it is not mandatory to give the state B, right? This is the exceptions that we are following the NFA. So what are those? First one, we can send an input symbol to a multiple number of states, right? Multiple next states. And the second one is, it is not mandatory that all the input symbols should be stays on the defined state. Okay, so this NFA is also same as DFA. So that is the reason why in the starting class I have told you that a finite automata is defined by using a 5-tuple notations. So all the finite automata contains the same 5 tuple notations but difference in the transition functions. So here same as in DFA, here in these NFA also we contains the 5 tuple notations, that is nothing but Q, sigma, delta, Q naught and F. Right? What is Q here? Q is nothing but finite set of states and sigma is nothing but finite set of input symbols and Q naught is nothing but initial state and final F is nothing but final states. And then coming to the transition functions. So in the previous DFA we are having Q cross sigma tends to Q. Right? But now in NFA we are having a transition function Q cross sigma tends to 2 power of Q. So how we are going to define that particular structure? That is nothing but if I take an input symbols Q is equals to Q naught and Q1 and sigma is nothing but input symbols A and B. So in order to perform these transition functions, Q cross sigma, that is a Q cross sigma tends to 2 power of Q. So what is this 2 power Q that we have already learned in the properties of a language, functions in the language. What is this 2 power Q we represent? We represent it as a power set of a language. So what is this power set contains? We will be discussing. What is Q here? Q is nothing but Q naught and Q1 and sigma is A and B. When we perform a cross operation between these two, I used to get Q naught on A, Q naught on B and Q naught, Q1 on A and Q1 on B. Right? And these 2 power of Q. What is this 2 power of Q? The power set of the Q. What is Q here? Q naught and Q1. So I used to get Q naught, Q1, Q naught comma Q1 as well as a null. Power set is nothing but it produces all the outputs including with the null set. So if I take a problem like NFA which accepts string AB or else NFA which accepts, or rather than accepts we can call it as which contains string AB. That means any length string you can take, in that you should contains a AB. So further the NFA will be like I start with Q naught, right? I should contains A and B and I reach the final state Q2. Before that AB I can contains any number of A's and B's and after the AB I can contains any number of A's and B's. So here see, look at here in Q naught I contains a input transition for A once and in the Q naught itself I get again one more transition on the A. This is nothing but we call it as a multiple next states. This is nothing but we call it as a multiple next state. Now look at in the Q1 here. In Q1 we have a transition for B but we doesn't contains a transition for A. That means it is not mandatory, that is nothing but it is not mandatory that all the input symbols should be defined for the states. All input symbols should be defined for the states. So by using this example itself, you can able to understand the two exceptions that we are discussed in the NFA. Okay, so let us do the transition functions. Now Q naught on A. Q naught A itself it is going to Q naught as well as a Q1. Q naught as well as a Q1. So therefore, I can simply give a mark to right. And next Q0 on B, it is going to Q0. Q1 on B, it is going to Q2. 3 states we are having. Q2. So we contains one more Q2 on A, Q2 on B. Q2. So we will get Q1 comma Q2, Q2 comma. Okay. So Q2 on B, it will be goes into Q2 on Q1 on B, it is going to Q2, right? And Q2 on A, it is going to Q2 itself, and Q2 on B is also going to Q2 itself, right? This is how the transition functions will be occur. So this is about the non-deterministic finite automata. So based on by using this example, let us know clearly define how these non-deterministic finite automata will be working out. The first question is NFA with epsilon is equals to 0, comma 1. That is nothing but what is this? This is a state input symbols. These are nothing but input symbols. Accept all strings with 0, 1. With that is nothing but string starts with 0, 1. Accept all strings starts with 0, 1. That means what is the meaning of this question? First of all, we have to understand by using an input symbol 0 and 1, we have to draw the finite automata or non-deterministic finite automata which accepts all strings starts with 0, 1. Starts with 0, 1. So I start with the Q0, right? Starts with 0, 1 means what are the possible language strings that I used to get? 0, 1, 0, 1, 1, 0, 1, 0 and so on. Any length string that it should starts with 0, 1. So here I starts with 0 by reaching Q1. On seeing 1, I reaches the state called Q2. Right? After 0, 1, I can get any number of zeros and ones. So here Q2 I am just giving 0 and 1. So the Q2 itself, it will become a final state. So therefore I just don't bother about Q0 on 1 and Q1 on 0. Right? So that means it is not mandatory to give all the input symbols in the NFA. So I just leave as it is. Right? So by using this transition diagram, we are going to draw the transition table here. Right? So here Q0 on 0, where it is going? It is going to Q1. Q0 on 1, it is going to the state called Q2. Right? And Q1 on 0, we contains a null epsilon. Sorry, here Q2 epsilon on. Q0 on 1, we contains an epsilon. That means epsilon is nothing but we don't have a no state, no transition. Q0 on 1 transition is not there. So I just represent it with the epsilon. Right? And Q1 on 0, we doesn't contain the 0 transition for Q1. So I represent it with the epsilon. And Q1 on 1. Q1 on 1, where it is going? It is going to Q2. So I represent Q2 here. And Q2 on 0 and Q2 on 1 stays on the same state called Q2 and Q2. So this is how we represent the NFA. Right? So let us take some more examples and solve the problems. Okay. The next one is NFA with input symbols 0 and 1. And the question is accept all strings of length at least 2. What is the meaning of at least 2? It should accept 0 length 2, at least 2, 0 length 2, 1 length string, 2 length string, and so on. The or else, 0 length string, 2 length string, it is nothing but 2 or more length string. More length string. So, first of all, let us write down the language. What is the language for this at least means? First, it accepts 2 length string 0, 0, 0, 1, 1, 0, 1, 1. And next, more means 3, 4, 5, and so on. What is 3 length string? 0, 0, 0, 0, 1, 0, and so on. Like as 4 length string, 5 length string, and so on. So, first I need to take, as this language is an infinite language, we should take the minimum length string, that is 0, 0. I starts with the Q0, right? On seeing 0, I reaches the Q1, and on seeing 0, again I reaches the Q2, right? So here, after this, I can see any number of ones, and here also I can see 1. That means I need to accept the 0, 1, 1, 0, and 1, 1. Right? After that, I can also execute any number of any length string also I can execute. So therefore, I give the Q2 with the 0 and 1. So that is nothing but this is the automata which accepts the string length at least 2. Right? Right. This is the next finite automata or a non-deterministic finite automata which accepts the string x, 0, 1, y. So here what is x and y here is nothing but x and y are sequences of zeros and ones. X and y are sequences of zeros and ones. That what is the meaning of the zeros and ones? That means x can be either 0 or 1 of any length, and y can be of 0 and 1 of any length. So that means the string should be in the format of x, 0 and y, or simply I can call that a string should contain the 0, 1 substring. A string should contain a 0, 1 as a substring. Simply we can tell. So let us write down the language. So the string 1, first it can be if it doesn't take any string length, I can represent it with the zeros and ones, right? And if I take 0, 0, 1, or else 1, 0, 1, or else 0, 1, 0, 0, 1, 1, and so on. Right? So look at here. In any string, we contain the string called 0, 1. Right? So for this we need to draw the finite automata or a non-deterministic finite automata. I start with the Q0. On seeing 0, I reaches Q1, and on seeing 1, I reaches the Q2. So in between 0 and 1, I can contains, before 0, 1, I contains any number of zeros and ones, and after 0 and 1, I can contains any number of zeros and ones. I can contains any number of zeros and ones in between before and after the 0 and 1. So that means if I take a string called a 1101, 0, 0. So as I start with the Q2 here final state here, so let me take a small string like 1 1 0 1 0 1 1 0 1 0. I start with the Q0. On seeing 1, I reaches the Q0 itself. Q0 on 1, again I reaches the Q1, sorry Q0. Q0 on 0, I reaches the Q1. Q1 on 1, I reaches the Q2. Q2 on 0, I reaches the Q2. Here, I starts with the start state and I reaches the final state. Right? So this is how any string that has to be get accepted in this NFA. Right? So the next one, construct an NFA which accepts a string starts with A over an input symbols AB. Right? Here, what is the question they have asked? A string should starts with A. String should starts with A and the input symbols that they have given is A comma B. The input symbols they have given is A comma B. The string should starts with A. Right. So based on the question, what will be the language? Right. String starts with A. Right. So that means any len string we can take, but the starting symbol should be a A. Right. So I can take single A. Is it right or not? Yes. The single A is also nothing but it starts with the A. A. I can consider any number of A's that starts with A. I can also take AB. ABA. Anything. After A, I can contains any number of B's. Right? So this is how the language. These are the strings that are accepted by this language. So before that language, I need to draw a non-deterministic finite automata. I start with a Q0 state, initial state, the start state. I should start with A and I reach the final state because a single A is also get accepted. Right? Q1. After A, I can contains any number of A's and any number of B's. So I just simply gives A comma B. So if I take a string called A B B A B, right? I start with the Q0 state here. On seeing A, I reaches the Q1. On seeing B, I reaches Q1. On seeing B again, I reaches Q1. On seeing A again, I Q1. And seeing B again, I reaches the Q. First, I starts with the Q0 and I reaches with the final states. So that means any len string that starts with the A will be get accepted. But what will happens if a string called B B starts with the B? If a string called starts with the B, so that this is a string. So this string starts with the B here. So I starts with the Q0. Q0 on seeing B, does a Q0 contains a state called B here? No, it doesn't contains a Q0 transition for the B. So therefore here itself it will get rejected. But where in the DFA, whenever if I see the B, it goes to the dead state. Right? But we're coming to the NFA, we doesn't contains any dead states. We just simply don't give the transitions for those type of productions. Okay? Right. The next one. Here the question is the same input symbol that we are taking A and B and the string ends with A. String ends with A. Right. In the previous question, we discuss the problem based on the string starts with A. Right? Now we are going to discuss about the string ends with A. So what is the meaning of string ends with A? The string, any length string that should ends with A. Before that A we can contains any number of A's and any number of B's. So based on that thing we have to draw the language. What is language? Ends with A. Single A is also nothing but itself starts with A and ends with A. So A, any number of A's, and B, A, any number of B's and A's, and B, A, and so on. Okay, so let us draw the transition diagram for this. I start with Q naught. On seeing A, I reaches the final state because a single A is also getting accepted here. Right. So I ends with the A here by seeing a Q2. So before A I can contains any number of A's and B's. So I just simply keep the Q naught A and B. I can contains any number of A's and B's before the A. That is the meaning of string ends with A. So take any string that ends with A. So B, A. I starts with Q naught. On seeing B, I stays on the Q naught itself. On seeing A, I reaches the Q naught. And on seeing one more A, I reaches the Q1. Or else simply I can keep here any number of A's also. Right? I starts with the A, right? I starts with the Q naught. On seeing A, I reaches the Q2. On one more A, I reaches the Q2. So here Q2 it is. So I starts with the initial states and ends at the final state. Starts with the initial state and ends at the final state. Okay. So in the previous question, you may get a doubt that why haven't given a loop here? Q naught for loop why haven't given is? Right? If I give the loop here and if I give a single A here, so if I take in single A here itself on A itself, it will be not get executed. Right? So that is the reason why we are not taking the loop over there. Right? And the next question is, construct an NFA which accepts the strings contains A over an input symbols A comma B. What are the input symbols? A and B are the input symbols. And right, what is the question here? String contains A. What is the meaning of the string that contains A is nothing but if I take any length of the string, that it should contains a substring called A. That it should contains a substring called A. So that means I starts with the Q naught. I contains a substring called A and I reaches the final state. So here itself I have reached the final state. The language will also accept a single A which will be act as a substring. Right? So A, any number of A's and any number of A followed by B and B followed by A. B followed by A. B followed by A and so on. But any length string, but it should contains a B. What are the strings that are not accepted by this language here? The string which contains only B's like B, B, and so on. So these are the strings that are not accepted by the language. Okay, so this language, this finite automata, what we are drawing here, that it should get reject these B's, and it should accept this language. Right? So I starts with the Q naught and ends at the Q2. I will seeing A. Before A I can contains any number of A's and B's, and after A I can reach any number of A's and B's. Before A I can contains any number of A's and B's, and after A I can contains any number of A's and B's. So that means if I take a string called A B, right, I start with the Q0. On seeing A, I reaches the Q2. On seeing B, I reaches the Q2. And on seeing A, I reaches Q2. On seeing B, again I reaches the Q. That means I starts with the initial states and ends with the Q. But if in case if I take a BB, Q0 on seeing Q0 on B, right? So I reaches the state called Q0, and Q0 on B again I reaches the state called Q. So that means from the initial state I am not going able to reach to the final state. But we're coming to this AB, from I starts with the initial states and ends with the final state. So that means this particular AB string is get accepted and this BB will be get rejected. Right? So this is called a construction of the NFA which contains A. Right? The next question that we are going to discuss here is two strings that we are combining this here. Those strings are x00y or x11y. And here x and y are nothing but they are two consecutives of zeros and ones. Right? Two consecutive zeros, x and y's are nothing but zeros and ones. Here we are going to execute two consecutive zeros and two consecutive ones. That means a string which contains a substring of 0, 0 or a substring of 1, 1. So I start with the Q0. Right? Q0 on seeing 0, I reaches the Q1. Q1 on seeing 0, I reaches the Q2 and I reach it as a final state. Right? So before, if I take this particular string x00y, 0, 0 is already there. X can be any 0 and 1, y can be any of 0 and 1. So I can take here 0 or 1 and Q2 can be any 0 or 1. And if I take x11y, I start with the Q0. On seeing 1, I reaches the Q3. On seeing 1 again, I reaches the Q4 final state. So here also for x11 also we contains x and y. So I starts with the any number of zeros and ones. By seeing 1, 1, I reaches the final state. After reaching the final state, I can again contains any number of zeros and ones. I can contains any number of zeros and ones. Okay, so this is how we need to construct the non-deterministic finite automata. So then after we are taking a substrings which contains 1100 or 1010 as a substring. So here I starts with the state called Q0. Right? These are the substrings. That means before and after that we can contains any number of zeros and ones. Right? So here we are taking two individual strings as a substrings. Right? On the input symbols, 0 and 1 are the input symbols. So I starts with Q0. On seeing 1, I reaches the Q1. On seeing 1 again, I reaches the Q2. Q2 on seeing 0, I reaches the Q3. And Q3 on seeing 0 again, I reaches the Q4, which will be my final state. So after seeing a 1100 as a substring, before that I can contains any number of zeros and ones, and after that I can contains any number of zeros and ones. While this is a NFA for the particular 1100. Then what about it 1010? Right? Q0. Q0 on 1, I reaches the Q1. Right? Q1 on 0, I reaches the state called Q5. Q5 on 1, I reaches the state called Q6. Q6 on 0, I reaches a state called Q7, again which it is a final state. Again which it is a final state. So why we are keeping a two final state means here we are having a two individual substrings. So when we are seeing 1100 as a substring, that we are ending with one final state. When we are seeing a 1010 as a substring, we are ending with the some another states. So when we are seeing 1010, before 1010 we can contain any number of zeros and ones, and after that also we can contain any number of zeros and ones. Okay, so this is all about your non-deterministic finite auto examples, and we are having a one more. Till now we discussed about the substrings and the string present in the particular finite automata. But now the question is, a construct an NFA for a strings in which the fourth symbol from the right end, from a right end is always A. That means any string length you take, A, B, A, B. That means one from my right end. 1, 2, 3, 4. The fourth end. The fourth symbol from the right end is always A. Right? So that is how you need to construct. So write down the finite automata. Right? 1, 2, 3, 4. Here A. One right hand, first, second, third, fourth one. This is first, second, third, fourth one is A, right? Right? Before the fourth symbol from the right end is always A. Right? Here we can contain any number of A's and B's. Here we can contain any number of A's and B's. Here also we can contain any A and B. Why I am not keeping here loop? You may get a doubt like, why I am not keeping a loop here? Q0, Q1, Q2, Q3 and Q4. So here Q4 and Q3 and Q2 and Q1, why I am not keeping a loop and why I am writing on a transitions A or B and transitions A or B and transitions A and B. Why I am writing like this? If I keep a loop, it may repeat it again more than one number of time to n number of times it will be repeating. That means here what is the intention of me keeping here A is nothing but the fourth symbol from the right end is always A. That means whenever I count a fourth symbol, that here it should be A. So if I keep a loop somewhere else, here or here else, what will happen? The particular strings will be get repeated and this A will not become a fourth symbol from the right end. So here that is the reason why we are not keeping the loop over there. So after reaching the right end A, I can contains any number of A's and B's. I can contains any number of A's and B. So if I change a question like fourth symbol from the left end is always A. From the fourth symbol from the left end is always A means I starts with the Q0. On seeing A or B, I reaches the Q1. On seeing A or B, I reaches the Q2. On seeing A or B, I reaches the Q3. Till now, how many symbols that we have seen? 3 symbols. A or B, A or B, A or B. And now the fourth symbol that it should be a and it should get executed. and then it should get executed. Final state. Right? After this AI can contains any number of A's and B's. After this I can contains any number of A's and B's. Okay, this is all. This is how we can take any number of examples based on this 4 symbol, 3 symbol, 2 symbol, or from the middle of that particular string. Any number of the strings that we can take and we can solve by using these methods. So this is all about your finite non-deterministic finite automata. Okay, thank you students.
Like, share and subscribe. Hit the bell icon for more updates.